All right, ladies and gentlemen, welcome to CalWeek, the beauty and joy of binary numbers, brought to you by myself, Dan Garcia. Woo! Great to have you all here. So delighted. I want to jump right in. There's a lot to talk about. I'm going to teach you how binary numbers work. I'm going to teach you a magic trick. I'm going to teach you the game of Nim, and there's a lot to do. So let me jump right in. Here we go. Ready? Action. Okay, and bloop. All right, bloop. So binary numbers. So you all know base 10 decimals. You might not have realized that we're using 10 digits, 0 through 9. And here's an example. If I told you that I made $32.71 dollars last year, you'd say, what does that mean? What that really means, and the reason I'm going to be very pedantic and go very slow about this, is going to be relevant for you as you see other bases. So I'm able to write on the screen here real quick. And what this means is it's 3. If this is, we start from the bottom side. This is the ones column, and the 7 is the tens column, and this is the hundreds, and the 3 is the thousands. So you might remember your teacher saying 3271 really is 3 thousands. It's almost like I got 3 boxes from Amazon, and they each say $1,000 each, and I got 3 of those boxes, and I got 2 of the $100 boxes or envelopes, and 7 of the $10 envelopes or boxes, and 1 of the $1 boxes. And if you add them all up, you basically say 3 times 1,000, that's 3,000, plus 200, plus 70, plus 1. And that ends up being 3271. But that's why we do this. He's like, Dan, this is silly. Why are you going so slow? Well, watch what happens as I then move to, drum roll please, dum-da-dum, binary. So not everybody raised their hand and said they know binary. Let me go slowly. Basically, because this base, this is a different base. Because this base is base 2, which is smaller than base 10, we start at 0 and we count up 2 different digits. So 0 and 1. Now you're going to say, well, Dan, if the base was bigger than 10, what would you do? And we'll teach you that when you get to Berkeley. We'll teach you that. We go into the letters. So 11 becomes A. Actually, 10 becomes, 9 is 9. 10 becomes A. B is 11. C is 12. So because we're base 2 and 2 is less than 10, we can just use 0 and 1. And by the way, these are binary. The reason we think about this is transistors that make up computers are only stable. They're only bistable. They're either stable with the current flowing on or the current flowing off. If they were stable in 3 different states, let's say current half flowing, current is electrons flowing, electrons moving. If it was stable in 3 states, we might actually be thinking about base 3. But because they're only bistable, they're either stable current flowing or not flowing, the light switch is either on or off, we call them binary. Only 2 states, binary. Like a binary star. So the word binary digits, if we take the BI and the TS from that, that's why we call this bits. So if you've ever seen 0 and 1 described as bits, it's because they are binary digits. So let's say how much did you make this year, Dan? I made 1101 in binary. Now, there's 3 ways of making this unambiguous. Because 1101, do you mean $1,101 in base 10? I don't mean that. I mean in binary. So we write it 3 ways. I either say the phrase in binary, or I write 0B in front of my number, or I write subscript 2. All 3 of those are ways to disambiguate it from being base 10 to be base 2. And we basically do the exact same thing. I have the left part of my screen handy for some scratch work. So watch this. I write this down and I make my columns. Watch how nice this is. I'm going to make my columns. And I do this, watch this. And this is, if you remember, by the way, this was 1. This was 10 to the 0, which was 1, back in the olden days. This is 10 to the 1, which was 10, if you remember this. This is 10 to the 2, or 100. And this is 10 to the 3, or 1,000. All these numbers are base 10. These are all base 10. So I really write base 10 so you know what I'm talking about. Okay? Well, we're in base 2. So it's exactly the same idea. Watch me. I'm going to make my table here. And I do the same thing. By the way, feel free to ask any questions on the chat, or you can even unmute if you have a question here. So this is the base. Remember, this was base 10. I wrote the base. So this is the base 2. I write 2 to the 0, 2 to the 1, 2 to the 2, and 2 to the 3. And what's that really? Well, that's in base 10. That's 1 in base 10. This is 2 in base 10. 2 squared is 2 times 2. 4 in base 10. And this is 8 in base 10. And this keeps going. 16, 32, 64, 128. You can play a game. How high can you go? Compete with your friends. 128, 256, 512, 1024, 2096. It's kind of a fun thing. 2048. See how far you can go. All right. And then I write my number. 1, 1, 0, 1. And I'm saying, basically, I got 1 package of 8 from Amazon. 1 package of 4. 0 packages of 2. So I didn't get any of those. And 1 package of 1. So if I got an 8, a 4, and a 1, 8 plus 4 is 12, plus 1 is 13. Get it? Okay. So that's how to convert binary to decimal. If I give you binary, 1101, you can now convert it to decimal. 8401. Isn't that neat? Okay. So let me clear the screen. Okay, and let's see what the next slide has. Okay. Now, this is a little harder. This is the opposite. What if I want to convert from decimal to binary? So now I've got my 13. And by the way, this is animated, so I actually can take this through the animation. Watch me. So I start with 13, and it's exactly the same conversation you had about Amazon boxes. I've got boxes. It's like this. Here's my analogy. I've got 13 eggs I need to ship back to Amazon because those eggs were sour and not very good. So I got 13 eggs. What do? Well, I can, here I go. I can, and let me make sure I spotlight myself for everybody. Yep, okay, got that. Okay, so I do the following. So I ask myself, well, I got a box that holds 8. And by the way, Amazon will only take boxes that are completely full. Only take boxes that are completely full. So that's a big deal. So that's boy, what do we do? So I got 13, and I can only sit back boxes that are full. So let's do the following. Here we go. So let's do this one. And let me go here, and I'll show you here, the animation here. Okay, boop, there. Okay. Watch this. Ready? And animation. Bloop. Okay. I ask myself, where's my animation? Okay, I ask myself, I'm waiting for my animation to start here. I have a little program that's about, see, it went too fast. It was already behind it. I say to myself, okay, can I fill, Amazon will take a fill box. Can I fill a box with 8? With 13, if I have 13 eggs? The answer is yes. So that's 1. So how many? And then I ask, how many of those boxes can I send back? Well, I can only send 1 of those back. And so that's 1. Then I subtract however many I'm sending back. How many do I have left? Subtract 13 minus 8 is 5. And I ask, and then I move to the next column, and I keep asking this question. And so this algorithm I'm using at the bottom is basically the algorithm I'm describing right now. Can I fill a box of 4 with 5 eggs? Yes, I can. So how many of those boxes can I fill? 1. I put a 1 there. How many? If I send 4 away, how many do I have left? 1. And I do the. Can I fill a box of 2 if I only have 1 egg? I cannot. 0. Keep going. Can I fill a box of 1? Yes, I can. How many of those boxes can I send back? 1. See that? And so guess what? 1101, if you remember from the last slide, 1101 was 13. Well, this is reversing the process. So here's 1101 is 13. So now you can go from 13 to 1101. That was the last slide. And you can go from 1101 to 13. That's pretty cool. Okay. Now let's play with binary numbers. This is actually some fun. So if you know binary numbers, you might not know what I'm about to show you. Let's do 1101. Let's just play with that again. 1101, we know that's 13. So this is like, if you didn't know, make a little table here. This is base 2, this is base 10, and this is my 13. What happens if I take a binary number and shift it left by 1 spot? So watch, I move all the things, shift left. Everybody kind of, it's like all the cousins are like hanging out in bed watching a TV show. Everybody move left by a spot. So when I shift left, this becomes 1101, and then you put a 0 in the place. Everybody shift left, and there's a gap there. So Let's look at it. Well, let's look at it. Remember, this is 13. Now, the columns are 16, 8, 4, 2, and 1. This is 2 being reused as both the base number and the column number. So if I do this, what happened? So 16 plus 8 plus 2. Well, 8 plus 2 is 10, plus 16 is 26. What just happened to the number? Mystery. What happened to that number? It doubled, didn't it? So now you know if I take a binary number, and by the way, the thing reverses. This goes both ways. Look at this. This goes, I can now say, what if I had a 0 here and I shift it to the right? Well, that would say I divide it by, if there's a 0 in the lowest position, I divide it by 2. Isn't that interesting? So 1101 goes down to, so 11010, which is 26, would go back down to 13 if I shift it to the right. If I shift it to the left, I double it. Isn't that kind of a fun little thing? So that's an interesting thing. Interesting thing number 2 is I can actually do normal mathematics on these numbers. So you say like, well, Dan, what's, I don't know, what's, let's do this one. Let's do a simple one. What's 101 plus, I don't know, 11? Well, 101 is going to be a 5 because that's a 4, 2, and 1. That's a 4 and a 1 is a 5. 1 and 1 is a 3. This should be 8. Watch what happens. Ready, Bear? Watch with me. I'm going to go slowly. I'm doing normal addition you did in first grade, but I'm doing it in binary, in which each slot can only ever be a 1 or a 0. So 1 plus 1. What's 1 plus 1? 2. But I can't write a 2. I can only write a 0 or 1. So really it is 0 and 1 carries. Now 1 and 1. What's that? 2, which is 0 and 1 carries. What's 1 and 1? 2. 0 and 1 carries, and then I bring the 1 down, and guess what? This is 8, because that's 8, 4, 2, and 1. See, look. See, it works. So I can either take these two. If I said, well, what's 101 plus 11, Dan? I can either go to decimal, add it there, come up with the 8, and then go back, or I could just go straight here, just go straight down and do it in binary. Isn't that interesting? So we can play with this. And that's kind of a really fun thing to be able to explore mathematics, either shifting left, doubling, shifting right, when there's a 0 in the right spot, having, and it's exactly right. So Johnny brings up a point. When you shift left, it's like multiplying by 10 in base 10. It's like multiplying by the base. In fact, it's always multiplying by the base. If you shift left, you're multiplying by the base. If you shift right, you're dividing by the base. It's exactly right. This is kind of really cool. Neat stuff. All right. So now you are ready for the Josephus problem magic trick. Woo! Okay, this is going to blow you away. I have, where's my number of participants? 22 people. So first I'm going to teach the magic trick. Here we go. If we were in person, this is a much better trick in person, by the way. Okay, let's just show. We stand in a circle. Every other person sits down. So you start with the 1, and that first person stands. Okay, so I'm going to cross them off. I'll use red to say they're going to sit down. So I would have people standing in a circle, and that usually this is great, by the way, in a camp where everybody can sit down where they're actually staying. You can make them all in a circle, kind of like duck, duck, goose, and just have people stand or sit. It's a great magic trick to do there. So we would do that we would do it if you had come to Soda Hall, if you'd come to UC Berkeley, we would have been in Soda Hall, which is the computer science department building, and I would have done this in a classroom. And we would have tried to move people around to do that. All right. So every other person sits down. And as you loop, once you come around the circle once, you keep playing the game. Every other person sits down. And the question you ask is, who is the last one to survive? The magic trick is, I know, based on the number, the maximum number of people, 5, who the last one to survive is. And I predict it's going to be 3. So I'm going to keep this as a secret. I predict it's going to be 3. But you don't know this, okay? Only I know this because of the mathematics of what I just taught you in binary numbers. There's a connection. You might guess there's a connection of binary numbers. All right, here we go. Let's try it together. So stand or sit. Stand, I'm going to circle. Sit, I'm going to cross off. Let's try it together. Here we go. So stand. So 1 stands. They survived the first day. 2 sits. Ooh, sorry, 2. 3 stands. Ooh, 3 survived 1 day. 4 sits. 5 stands. By the way, you might guess that first round I cross off all the even numbers. That makes sense. But once I go around once, now it changes up. It's no longer so clear. 5 stands, 1 is going to sit. 3 stands. 3 survived a second day. 5 sits, right? We're just going on who's still standing. 5 sits. Who's left? 3. Am I right? How about an applause for Professor Garcia? Woo! I predicted 3, and 3 was the last one standing. Yay! Is that neat? Is that kind of cool? All right, so we're going to do this magic trick live. You ready for this? I'm going to write it down live. This is going to be really, really wonderful. Let me try this now. Okay, I'm going to go to the next slide, which is this cursor. I'm going to make sure I have like 19 different things to control here. Let me go here. Bloop. Okay, the magic trick revealed. First, we're going to do it together. I'm going to do it for you and then teach you how it works. But I left a blank slide to actually do it for you. Okay, here we go. So I'm counting. If I don't count myself, I'm going to count Gina as part of this. So I see 20. Where's my window? Okay, I count 23 people. And I'm 2 people, so I don't play. So I count 21 people. Okay, 21 people. Who's going to win? Dan goes to his brain. I say person 11. Like, how did I come up with that? So let's try this. Ready for us. Let's try it together. Here we go. Okay, 1, 2, 3, 4, 5, 6, 7, 8. I'm going to do 21, okay? 9, 10, 11. Thank you for your patience, by the way. I didn't know how people were going to be here. I was hoping I would have like 60, but actually there's been a lot longer if I had 60 people here. 13, 14, 15, 16, 17, 18, 19, 20, 21. Okay? You so far so good? All right. And just to make it fun, I'm going to put your initials here. So, GG. Here we go. Let me get here. Okay. GG. I'm just looking down the list. AK. There's 2 AKs. AK and AK. I'm just going through here. There's an AS and an AT. AS. AT. Who else is on my list? BD. By the way, I hope nobody drops in here. BD. Keep going. This is wonderful. I got a BRBH. BR. BH. You know who you are by looking at the participant list. CB. CJ. I hope this is not revealing too much information for people who didn't want to be recorded. HT. There's 2 HTs. HT. Oh, so this HT is the winner. So this one is they both last name. Okay. Nobody knows this person. Henry. Okay, Henry's the winner. Okay, HT. Here we go. JL. Keep going. JL. JR. JP. JR. JP. Keep on going. KM. KM. MC. Hopefully you're feeling like you're being part of this and you're feeling connected. OAK. And P. Oh, somebody dropped out. Did I lose somebody? Oh, I think I dropped out. This is funny. P and TY. And I'm going to need a volunteer. I will have my iPad. My iPad will be member 21 as a stand-in. Okay, you ready for this? Let's do it together. I need some help because sometimes I mess this up, okay? So we always start with one survives. Okay, here we go. Ready? 1 circle. 1 survives. Woo! 1 survives. Sorry, AK. You get to survive, AK. Sorry, AS. Yay. Nope. Yay. Nope. By the way, back in the 50s, I'm just crossing off you can imagine all the even ones. They used to have a dance competition. If you ever watched the movie Grease, and what would happen is they just tap you on the shoulder when it's time to go home to sit down. So I'm just tapping people gently on the shoulder saying, you didn't make it to the next round of competition, and hopefully I'm doing this correctly and only sending home the even numbers. Okay, now it gets harder. Okay, so help me with this. 21 stands. Now 1's got to sit. Sorry. 3 survives the second round. Okay. 5 sits. 7 survives the second round. 9 sits. By the way, who's my winner? 11 survives to the second round. Congratulations, 11. Congratulations, Henry. Sorry, 13. 15 stands. Sorry, 17. 19 stands. Okay, here we go. Sorry, 20. Let's keep going. Now, try cross out 23 gets to survive another round. Sorry, 7. 11 survives another round. Sorry, 15. 19 survives another round. Sorry, 3. 11 survives one more round. Sorry, 19. Ladies and gentlemen, Dan Garcia, 11 survives. Woo! Let's have another applause. Huh? Did it work? How did I know 21 to 11? That makes no sense. How on earth did I know that? So, you want to know the magic trick now? Who wants to know the magic trick? Thumbs up, the magic trick. You want to see? Okay, I'll teach you a magic trick. Let's do this. By the way, this is weird that Zoom on the iPad doesn't let you write in white. If I'm writing on black, I should be able to write in white. I'm able to write in yellow. All right, here we go. So I started with 21. I started with 21. Okay. Now, let's first ask a question. If I had one person, who would win? Remember, you always start standing. Who would win? So I write winner. Winner. If I had only one person in the room, they'd be the winner, right? Because they always start standing. We stop when there's one person, so that's the base case. What if I had 2 people numbered 1 and 2? So let's try it. 1 and 2. Okay, stand, sit. Well, 1 wins again. Isn't that weird? So 1 wins again. Interesting. What if I had 4 people in the room? Let me now erase this and write 4 people in the room. 2, 3, 4. Let's try it. Stand, sit, stand, sit, stand, sit. Who wins in the 4-person case? Wait, 1 does. Can anybody see a pattern? Who knows whether there's a pattern there? Anybody can type or unmute. I think I've allowed you to unmute, not video. Yeah, 2 to the n wins. If you ever have 2 to the n, that's if a power of 2, so not a multiple of 2, but a power of 2. So 1, 2, 4. This, by the way, is not 6. We're talking about 8, 16, 32, like the columns that we used to have. If anytime there's a power of 2, 1 wins. Okay? Are we all okay on that? So this is part 1 of the proof of why this works. Okay? We're okay with that, right? So now, let me erase all this stuff. So now that I know that rule, here's a question I ask you. If I have 21 people, can you see the idea that we're going to play this game, standing and sitting, and then this number is going to get smaller, right? After the first person sits down, after 2 sits down, there's only 20 people. After 4 sits down, there's 19 people. And I keep going until there's 16 people. Do you agree with that? And the moment we have 16 people, if I stopped and said, all right, stop. Now renumber yourself from the person who was the next person to stand. If the next person to stand after that, I renumber you and I call you number 1, you're going to win. Does that make sense? So 20, they go 1, stand, sit. Okay, now there's only 19. Or now there's only 20. Stand, sit. Now there's only 19. Stand, sit, 18. Stand, sit, 17. Stand, sit, 16. The next person wins. Okay? Right so far? So we can almost go back to, if only I kept my thing. How many people now? 20 standing, starting at number 1. Once 2 has sat down, this is 21. 21. This is like there are 20 standing. You agree? And it's like this. If I renumbered now, with 2 being out, it's like if I renumbered at 20, it'd be like restarting it at 20. This is it like restarting at 19. This is it restarting at 18. This is, watch me, restarting at 17. This is like, ladies and gentlemen, restarting at 16. Huh? And we know if I renumber, they are my number 1 and they're going to win. You know that already. Isn't that neat? So I ask yourself, how do I get 11 from 21? Well, it's simple. I say, let me do this one now. Okay, so this is so cool. The mathematics of this are so brilliant. Okay, let's do this. So now here's 21. I need to get to 16 somehow. Okay? So here's what I want to do. I want to somehow say the following. Well, the biggest, maybe I write some notes here. So the biggest power of 2 smaller than the initial number that's what that is, right? 16 is the biggest power of 2, smaller than that. I keep going until I have a power of 2, because 21 is not a power of 2. By the way, if 21 were a power of 2, like let's say I started with 32, I'd say number 1 wins, because you know that when there's a power of 2, the number 1 wins, okay? So now watch this, 21, 16. Well, how many people, watch this, I'm subtracting this, how many have to sit down? How many did I have to cross off? Where's my green? How many I had to cross off? Let's count it. 1, 2, 3, 4, 5. So 21 minus 16 is 5 had to sit. You agree? 5 had to sit. Right? So now, if 5 sit, I'm asking a question of the group. Do we play the game by saying, okay, let's play this game, sit, 5 people in a row? No, it's every other person. So to get to those 5, I have to have gone through, times 2, 10 people. And because I start, because 10 people had to sit down, and that's the 2, right? So here's the 1, 2, 1, 2, 1, 2, 1, 2. Here's 1, 2, 3, 4. Whoops, I went too fast. 1. That's 2. That's 3. That's 4. And wait. 4. I think that's right. This is 4. That's right. And this is 5. 1, 2. There's my 5. 1, 2, 3, 4, 5. There's 5 pairs. Okay? Now, who's the next person? I add a 1. And that's 11. And that's my answer. You want to try it again? So, now, let me show you why this is so beautiful mathematically. 21. What does 21 look like in binary? Let's do that. Let's do the egg question. Can I fit into 16? Yes. So there's a 1 for the 16. There's my 16s column. Can I fit in 8? How many are left after I subtract 16 of there? I say 5. Okay, so can I fill a box for 8 for Amazon? Nope. If I have 5 left, can I? Sorry, I just right here. I have 5 left. I should cross it off. I have 5 left. Can I fill a box of 4? Yes, I can. Now I have 1 left. How many? I fill 1 of them. Can I fill a box of 2 with 1 egg? No. Can I fill a box of 1 with 1 egg? Yes, 1. So this number is 10101 in binary. So 21 is 10101. It's kind of a pretty number. Okay? Now, what is the biggest power of 2? The biggest power of 2, ladies and gentlemen, is 16. And that looks like this. And you told me I need to subtract them. And you also told me I can do mathematics in binary numbers. So let's make a line and let me subtract this. Watch what happens. If I kind of draw this line here, this goes away. 1 minus 1. All I'm doing is subtracting this 1 here. This goes to 0. This goes to 0 here. You agree with that? And basically, I keep all of the remaining guys. These are all, this minus 0. Look, this minus the 0. They all stay the same. So all I'm basically doing is taking off the topmost bit. Okay? Then, times 2. Well, we know what that means. That's shift to the left. Watch this. Shift to the left. 0, 1, 0, 1, 0. Is that right? Yeah. And that is 10. Look, this is the number for 5. By the way, this is the number for 5. Remember I told you I could either subtract this way, or I could go into binary, go down to binary, and go back? They all work. This is 16. It's 21 minus 16. If I could either subtract them in decimal and then move 5 over and look over there, or I can say, well, that's binary, subtract it, and then go back this way. So here's 21 minus 16 is 0101, which is 5. I double it, I get 10, which is 1010. And now, stay with me. I wish I had left myself more room. I need to add 1. So I just say plus 1, plus 1. And I get 1, 0, 1. And remember, the 0 plus 1 is 1. And this is 11. And that's how I did it. So you could, if I take 21, let's do it in our heads. 21, what's the answer? What's the biggest power of 2? 16. Subtract it off, it's 5. Double it, that's 10. Add 1 is 11. Answer is 11. Or, here's the cool thing. Here's another way to do this. Remember this 1010? I somehow got the leftmost one to go away. Right? Because look, I subtracted off the biggest one. The leftmost one is the biggest power of 16, power of 2, which was 16 here. That goes away. Then I shift everybody left. So imagine, here's my number, 10101. What I'm really doing is taking this one away and then really putting it there. Why? Because if I consider this number, look at this number here. What's the answer? 01011. The answer is 01011. That's 11. This is 11, which is the same thing you get if you take the leftmost bit. Why does I take the leftmost bit? Because here, the leftmost bit is this guy there. I just explained why the leftmost bit goes away. Shifting left means they all move to the left, which is what I just did here, and I was doing that. And if I then add back the 1, which basically takes the leftmost one, rotate it over and put it on the right, and read that number out, and you get 01011. Ladies and gentlemen, that's the answer. Isn't that neat? So let's try another number, okay? Let's do it fast. Ready? I got 13 people. 13 people. So the 2 ways of doing this. Here we go. Quick quiz. Ready? 13 people. I subtract the biggest power of 2, which is 8. That gives me 5. I multiply times 2. That gives me 10. And I add 1, and it gives me 11. Okay? So it's the same, by the way, this is the same number. Isn't that fascinating? That 13, if I had 13 people, it's also 11 who wins. Okay? Now, watch me do this in my head in binary. 13, what do we do? What's 13 again? Isn't it 1101? Isn't that right? Well, Dan, the answer is, watch this. I move this to the end. It is 1011. Ladies and gentlemen, 1011, which is 11. So if I had 13, 11 wins. Isn't that cool? Woo! So that's how the magic trick works. You take the number, convert it to binary, take the leftmost bit, move it to the end, and then read the number out again in decimal. That's it. You're going to say, well, Dan, do it one more time. Okay, give me another number. 27. Let's see how fast I can do it. 27. That's let's just fast. 16. 8, 4, 2, 1. 16. How many's left? 9. That's 9. I think this is 27. Is that right? Maybe I did it wrong. 16. Oh, wait. 16 minus 27 is 11. That's 8, 2, and 1. That's my number. Now you say, Dan told me all I do is I take this leftmost one, and I put it over here. So the answer is 10111. Well, I know this is 7. I know this is 16. So the answer is 23. Let's double check it. 27 minus the biggest power of 2 is 16. That's 11 times 2 is 22 plus 1, 23. So some people can do binary really fast. Some people can do this math pretty fast, but this is 23. So 27, who wins? 23. So you can now play a game with yourself. Make a little table. You make a little table. Literally make a table for n, and who wins? 1 wins. 2, 1 wins. 3, well, they have to do a little math here. 3 minus the big power. 3 minus 2 is 1 times 2 is 2 plus 1 is 3. 3 wins. And keep filling this table in. Okay? So I give you all an assignment to fill this table in, and then you can figure out how to do this in your head and do it faster. The fastest you can do it, you can either do it by thinking the binary, or, and by the way, here's a way for me to do 3 really fast. Watch. 1, 1. Ready? When this goes this way, what's that number? 1, 1. So therefore 3 wins. So for smaller numbers, I can actually do faster in binary. I know 4 is 100 because it's 4, 2, 1. So that means 1. So 4 is 1. 5 is 101. Therefore, it's 3, because when this goes this way, it becomes 3. So 5 is 3. And I can do it in my head. 6, which is 110, becomes 101, which is 5. So I can do that in my head for smaller numbers. 7 is 7, because 111, that stays the same. 8, we know, is 1. By the way, let's try 8. 8 also works. Watch. Ready? Take the 1, move it here. That number is just 1. So any power of 2 is always 1 with a lot of zeros. Well, when you take the leftmost 1, it becomes 0. You put it to the right, it becomes 1. That's why all powers of 1, all powers of 2 are 1. Anyway, fun. So 9 is always 3. By the way, here's a fun thing. Anything 1 plus a power of 2, here's 1 plus a power of 2, like 9 or 17 or 33, always has the form 1, 0, and a 1. Well, if I take that over, it's always end up being 3. 1, 1 is 3. This is a 2 and a 1. So all the ones that are 3 are, can you guess it? 5, whoops, 5, because that's 101. 9, that's 1001. These are all 3s. These are all 3s. Okay? 17, 10001. 3. Isn't that interesting? So you can kind of do all this proofy stuff where you can play with that and explore that space. All right. Phew! Let me teach you the game of Nim. Here we go. Hope that was fun, by the way. A lot of fun mathematics there. Here's how this works. You got several heaps of beans. On your turn, you select a heap and remove any positive number of beans from it, maybe all. The goal is to take the last bean. Okay, let's play it. I'm going to play against the class. Okay? So you first choose a heap and you cross the beans. Let's see if I play against you. Somebody can type the chat, and you want to type in a form of this. You want to type it like, I'll just see if I can get my cursor into the chat window. You want to type like, take, 3 from the 7 pile, like that. That's what you would say, okay? So, you want to go first or second? Anybody types first gets to choose. Whoever types first gets to choose. First or second, go. The goal, by the way, is to take the last bean. You want to clear the table. You want to clear the table. So this is where you interact with me, and you'd say you can either turn your microphones on or you can type, and I want you to make a move. Go ahead. Here we go. So take one. You want to move first? All right. So Arthur wants to move first. Take 1 from 5. Okay, here we go. So now this is 4. 2, 3, 4, 7. All right. Somebody else can go. Somebody else who's not Arthur. Somebody else. So I made a move. Oh no, sorry, that was my move. That's my move now. I'll take 1 from this one. Now it's my turn. So now it's 2, 3, 4, 6. Now it's your turn. Somebody else. I gotta have different people. Okay, take 2 from 2. So erase that thing. I love it. I have no idea what I'm doing. I don't know how this game works. Boy, I'll just take 1 from there. I don't know what I'm doing here. 2, 4, 6. All right, somebody else, some different person. And you can either speak it or type it. We're playing the game together. And I hope I win this game. But boy, I think it looks like you're going to win this. So let's try it. Anybody. Okay. All right. 2 from 4. Okay. 2 from 4. So 2 from 4. And now there's 2 left. I'm going to take the whole 6 pile. Okay. Somebody else's turn. Boy, I hope I win this game, but I may not. Let's see. Your turn. Anybody? One from 2. Okay, so you took 1 from the 2. Take 1 from the 2. And I'll take all the 2s. Oh, I messed up! And you win. You took the last piece. You win. Yay, you won. Applause for the students. I messed up. Isn't that neat? Now, here's something fascinating about Nim. I can always have you win. You're like, what? I said, yes, played with a beginner, I will always guarantee that person wins. It's one of the most beautiful elements of Nim. So what I want you to do now is, I've got a meeting in 10 minutes, so let's make sure. I was going to have a time where you all play each other, but I want you to think about this. But let me tell you how this works. Let me tell you the secret behind Nim. Okay, this is really fun. We would have had more time. If we had more time, we would have touched this. Here's the secret. Here we go. Clear. Okay, I did that. So I was going to play her up and do this, but we're going to jump here. is this game winning or losing? So in your games, you want to get the last move. You want to ask yourself, is the game winning or losing? And then, if it is winning, here's how to tell whether this is winning or losing. To win means you'd win the game if it's your turn. Lose means if you had that position, you would lose. You first take each heap and put it in binary. Isn't that fascinating? So 2 becomes 1, 0, 3 becomes 1, 1, 5 becomes 1, 1, and 7 becomes 1, 1, 1. Now, watch what happens. Then you take what's called the Nim sum of those heaps. It's like you add them up, but you don't carry. And what not carrying means is, if I have an even number of ones, it's a 0. If an odd number of ones, it's a 1. Let's try it. 1, 1, 1. That's an odd number of ones. That is a 1. Because 1 plus 1 plus 1 is 3, which is 1, 1, but I don't carry. So it's 1, carry the 1, but I don't carry. So I write the 1 there. So I basically write the lower bit of the sum. And now, so I don't carry. 1, 1, and 1. Another 3. I write another 1 there. 1 and 1 is an even number. I write a 0 there. Does that make sense? Okay. So I got, this by the way is called the XOR. The XOR is a really powerful operation. You'll learn about this when you take my classes. So XOR is basically this. For every column, a parallel XOR is for every column. If it's an odd number, you write 1. If it's an even number of ones, you write a 0. Okay? And now, here's the cool part. If it's 0, you look at this sum. Is this all zeros? If it is, it's a losing position, meaning bad, meaning you want to give it to your opponent. Otherwise known as a second player win. Otherwise, if it's not, this is not 0, you should be able to win from this. And now here's the part. How do you win from this? As you might guess, you're going to take things from columns to make the sum 0. You're saying, Dan, if the rule is when that sums to 0, well, after I'm done, if you recalculate it, it should be a 0. Well, let's think mathematically about this. XOR is all about an odd number of ones. So watch this. I go here and I actually look at all those guys, and I have to flip all those. I have to flip all those light switches in some sense. Those light switches are not set correctly. So here we go. The winning move is you start by saying, what is the MSB stands for the most significant bit in the Nim sum. And this is in the 2's column. Remember, this is the 1's column, the 2's column, the 4's column. Okay? Most significant bit is in the 2's column. Step 2. This is an algorithm. By the way, I'm giving you an algorithm. You find a heap with a 1 in that place. So look, I got 3 heaps. The 2, the 3, or the 7. I could make a move on any one of those 3. Isn't that fascinating? I can make a move on 2, or on 3, or on 7. That's kind of interesting. I'm going to choose to make a move on the 2. Watch what happens. Watch what happens. Watch my animation. And what I do is, the last part of the algorithm is, I invert all of the bits from the sum to make it 0. So for every time that there was a 1 here, that means I got to flip the odd or evenness of that. This means there's an odd number of 1s. I've got to flip it. Watch this. That sometimes means, watch what happens, sometimes means take a 1 and make it a 0. That means I'm taking 1 away from that sum. That was 3, I made it 2. But if it were a 0, watch it. If it were a 0, sometimes it means take a 0 and make it to a 1, which takes a 3 and makes it to a 4. Look, there's now 4 in that column, and 2 in that column, and 2 in terms of number of 1s. This is like the number of 1s. And they're all even. If they're all even, every column gets to be 0. That's it. Isn't that fascinating? That's the whole strategy. And here's the best part about it. Because this is now 0, so let's play the game 1, 3, 5, 7. That's called a losing position. It means that anything you do is going to disrupt the balance. Why? Because anything you do is going to change either a 1 to a 0 or a 0 to a 1 on only one of the rows. And by changing only one of the rows, you're going to disrupt everybody that has a 1, whatever you move it down to, this is going to change. You cannot make a move to take a 0 and make it a 0. It's impossible. You have to make this some 1s there. So let's make a move. Somebody make a move. Somebody type a move from 1, 3, 5, 7. Just make a move. Let's see what happens. But I guarantee the Nim sum is going to be non-zero after you move, which means I could win. And then I'll make a move to make it 0. Then you'll make it non-zero, and I'll make it 0. We keep having this wonderful flippy-floppy. Every time it's Dan's turn, it's 0. It's non-zero. It's not 0. I write not 0. And every time it's your turn, it is 0. So non-zero, I gave you. So I had, what did I have? I had 2, 3, 5, 7. I give you a 0 of 1, 3, 5, 7. What are you going to give me? So somebody make a move. Take one from, wait, so somebody make a move for me, because somebody type the move. I didn't see it here. I need a move on 1, 3, 5, 7. Any move on one, anything. Whatever you do, doesn't matter, because you're going to lose anyway. I'll show you. Somebody type a move real quick. If not, I'll make one for you. Take 2 from 7. Okay, watch. Okay, watch what happens. Okay? That becomes 1. Now watch what happens. This becomes a 5. Watch what happens. This becomes a 5. And so you are actually only changing the state of this middle bit. So I guarantee that this 1 plus 3 nim sum of 1, nim sum 3, nim sum 5, nim sum 5 is this bit alone. That's the only bit you changed, is going to be a 2. And why is that, by the way? Because 1, 0, 1 and 1, 0, 1 are the same, and so they kind of cancel each other out. This one are both even, that one both even, they kind of cancel each other out. And 1 nim sum 3 is 2. So you gave me non-zero, which is 2. How about this? You gave me, what did you say? 1, 3, 5, 5. How many for time? Yeah, I'm good for time, okay? What's my move? Let's do it. Let's do my algorithm. Okay, let's clear it up. Let's do my algorithm. So these both cancel. I don't even look about these. I ignore this. 1, 3, 5, 5. I'm just playing 1 into 3. Let's just do 1 into 3. I get 2. Remember I just said 1 into 2. If I can I go back one? There, okay? Let's clear this out. Okay? So I got, it was 1, 3, 5, 5, right? Okay, so 1, I believe, 1, which is 0, 1. And this is a 5, 1, 0, 1. Just try to clear this up a little here. So it's 1, 3, 5, 5. Okay, 1, 3, 5, 5. Now, what do I do? What do I do on my thing? I think I make 1 and 1 balanced. So I think, let's see, 0, 1 plus 1, 1. What's the sum? 0 plus 1, 1. 1 plus 1 is 0. 0 plus 1 is 1. It's 2. Let me go back up. Actually, look at this. What are the columns, what are the rows that have a 1 in the 2's column? That's the leftmost one. Not here, not here, not here. I actually have to move on the 3. And what do? I flip all the bits that are 1s down here. Whenever you see a 1 down here, I flip the bit. So that means I flip this bit, and this becomes a 0. Well, guess what? 0, 1 is a 1. So this becomes 1, 1. Now, here's what's interesting. Now I have the game 1, 1, 5, 5. And this is what's called a symmetric game. It's like playing a mirror. 1, 1, 5, 5. Whatever you play, I'm going to copy you to play this in. So basically, you're going to disturb something on one board, and I'm going to take it to the other side. If you disturb the 5, I'll take on the other 5. So somebody make a move now. Somebody make a move quickly. Either take a 1 or something from the 1 or something from the 5. And I'll show you my responses to equalize it. Go ahead. Somebody make a move now. Somebody type. Come on. 1 minute left. Got to run. Take 5 from 5. Okay, watch. I take the whole 5. I just copy you. Take 5 from 5. You take the 1. I take the 1 to win. Now, watch this. What am I going to do if I'm playing against a younger player? What I do, watch this. You got 1, 1, 5, 5. Once you take this all 5, I've got 1 and 1, okay? We know this is 0. This nim sum to 0. 1 plus 1 is nim to here. 1 plus 1 nim sum to 0. I want you to win, so when I play a younger player, what you do is rather than take all the 5, you take all but one of the 5s. I make this a 1. And now you're going to win. Let's just watch how all the CalWeek students win. CalWeek, Dan, CalWeek takes the last piece and you win. So when you're playing against a younger player, rather than take all of one of them as you're getting down to the bottom, just take all but one, and then you'll be able to flip it, which is what I did for you. And if you remember this, we actually had the game. Actually, what was the game we were playing earlier? I took all but one. It was 2-2. Remember, it was 2-2, and you took 1 from the 2. And I could have copied you. The correct strategy is to copy you, and I take 1 from the 2, then you take that, and I take this to win. That's not what I did, if you recall that. Remember this? What I did is I said, you took 1 from the 2. I said, well, let me do the opposite of that. I was supposed to take all of them. I'm going to take 1 of them to copy you. I took all the 2, giving you exactly 1, and then you won. So that's it. That's how to play Nim perfectly. Isn't that interesting? So you get this. You first start by doing this, go to the side. In your head, by the way, if you can do this on the side, it's kind of nice. There's some shortcuts for doing this, by the way, which is you have some shortcuts to this, which is once you have, like, remember I have here 2, 3, 5, 7. I know that 2 plus 3 is 1. So in my head, I know the 2 nim sum 3 is 1. So I say this is him as 1. 1 nim sum 5 is 4. This becomes a 4. It's like playing 4 and 7. So the way to do this is you take this here and I make this a 4. And that would actually work. So I claim that making that a 4 works. Watch. If I make this a 4, what happens? 100. Let's do it again. 0, 1, 1, 0, 0. 1, 1, 0, 0, 0. 1, 1, 0. See? So you can kind of take pairs and get a number, which is kind of a cool thing. Anyway, that's the game of Nim. Good luck playing it. I hope you enjoy it. Play against your parents now. You'll be able to whomp them if you have a little piece of paper to do some scratch stuff. You'll never lose this game again. If you know if it's a winning game, by the way, go first. If it's a losing game, let them go first. That's it. Thanks so much. Nice to see everybody. Happy Cow Week, folks. Go Bears! Woo!
Thank you.
My pleasure.
Thank you.
That was fun for me. Thanks a lot, folks. All right. Stop share. Stop recording. Bloop.